Hello everybody. This is the short video for step one of the VaR project, Value at Risk and Hedging. And we're going to do a couple of things in this video, really simple and straightforward, it won't take you too long. I'm starting with a spreadsheet from the last project we did, which uses the the market model, sharp optimization, and the three-factor model, sharp optimal portfolio. So all three of these portfolios are going to stay the same. We need to incorporate them in our analysis for VaR. Step one is to create a copy of the portfolio. I've done that here. I've created sharp 1 EG, sharp EG, and sharp 3-fact EG for Elton and Grover. Again, you're just going to come in here, do a move copy, ask for a copy, and then throw the new sheet in, change the name. The main point that you need to do, you don't have to change anything up here. Make sure that your weights are actually equations that are linking back to your variables. The main thing is pretty straightforward. You come over here where we have the equation for Sharpe ratio, and we want to change it to this equation here for Elton and Gruber. Now, R bar is the expected return of the portfolio. That's the annual return. And then your sigma is the standard deviation of the portfolio. This is the variance of the portfolio. And that's going to be this number up here for annual volatility. They don't have to be on a daily or monthly ratio. The scaling will be the same. Alright, so this is the current Sharpe ratio from the maximization. You're not going to see a huge amount of change in the annual volatility or the return typically when you go to this alternative maximization function. So again, all we want to do here, this is going to equal, so it's the volatility multiplied by the return, and then we're going to divide that by the quantity of the return. Use the caret symbol to square it, and we're going to add to that the volatility, and then we're going to square that to get the variance. That becomes the quantity. So we're at 4.34 when we go through our maximization routine. Typically you're going to come out fairly close to that number. So here we go under data, run the solver. We're still going to maximize that cell subject to all of our previous constraints. Hit the solve button. So you see we're still at 4.34. Our return has changed slightly, our variance has changed slightly. But what really makes a big difference here is our weights. And I'm going to pause this real quick. Alright, hopefully the pause came back okay. Just throw a line under here. So this is from our Elton and Gruber optimization, we're at 11.16. On our Sharpe optimal ratio, I was at 9.84. So the different maximization equation is changing the weighting of everything to a certain extent, as opposed to what we had here for our Sharpe optimal. And that's basically what you'll see, that there's a change. The expected return and standard deviation aren't going to vary too much. Your EG ratio from the get-go will be fairly similar, but your weights are going to change quite a bit. Alright, so that's step one of the project, and then we'll go to the next video here in a little bit. Thanks, bye.